All right, good morning, everyone. Welcome to Water Around the World, Local Problems, Global Solutions. My name is Elena Harkness, and I'm the Executive Director of Current. And on behalf of our whole team and our sponsoring partner, the Consulate General of Denmark's, the Trade Council, I'm so excited to welcome you here to this really important conversation, Money Down the Drain, Technologies to Reduce Non-Revenue Water. We are going to hear a lot more about the innovators today that are creating solutions to this important challenge, and some really important framing remarks from Andy Richardson, the chair of Greeley and Hansen, who is going to be sharing why this topic is so important for us to consider and why we can't afford to waste a drop of water. Just a few logistics before we dive into this conversation. So number one, this is a Zoom webinar. You're all familiar with that by now, but please submit your questions for our speakers in the Q&A tab and any general comments in the chat tab. Both of those are open to you. We'll be weaving in questions for our innovators throughout the presentation. Finally, this event is being recorded. The recording link will be shared out with all of you after the event, so please feel free to share it widely. Real quick agenda rundown. We will be hearing an opening welcome from Michael Peterson, who's the Senior Technical Advisor, Palo Alto, Consulate General of Denmark, and our sponsored partner today. And then, as I mentioned, Andy Richardson, who is Current's board member and also chairman of Greeley and Hansen, will be giving an overview of the problem statement. We always like to start these solutions-focused conversations with a sense of the problems we're trying to solve, grounded in the real world, why it matters, not only here where we're broadcasting from Chicago, but to our partners around the world. It's truly a global solutions marketplace. Then we'll have presentations from our terrific lineup of speakers today. Robert Montenegro, the Executive VP from Grundfos, Kent Culbertson, Eastern US Sales Manager from AVK, Karen Hsu, Solution Manager from Kamstrup, and Jørgen Koch, Managing Director of Leif Koch. Then we'll have Q&A from the audience kind of woven throughout, closing remarks, and we will wrap up right at 11 o'clock Central. All right, George, next slide. Let's see, I think we're having a slide. Oh, there we go. Just a brief overview of Current. So as the convening partner, why are we here? Why does everyone come together for these solutions-focused conversations? Next slide. We're here because we have common challenges that we are facing in our communities all around the world with respect for water. We all can agree we need more healthy water to drink and less flood water for our basements. But the way those challenges play out really varies all around the world, from region to region and from city to city. Next slide. At Current, we believe the urgent need is to come up with solutions and get them to ground faster. We really believe that it's difficult to do water innovation work and that we need help rallying faster, collaborating smarter to come up with the new ideas and technologies that will help protect our water, our health, and the environment. We know that water innovation is challenging. All of you that are here today to speak as innovators know this, that the problems we face in water are often too big or too complicated for any one company, organization, or government to tackle alone. And the collaboration that's required to bring these solutions to life is why Current exists. We're here to build partnerships among industry and governments, nonprofits, and others to try to bring these solutions into market, on the ground, faster, smarter. And today, I'm really excited about this conversation and all of these Water Around the World series because they're highlighting the trade relationships between cities and places that have really excellent solutions in water, bringing them to ground in other places. And this sort of global trade partnership and innovation community is really an exciting part of Current's community and what we're so excited to foster. Next slide, George. Current exists to be an unbiased advocate for only the best water solutions and policies. So the group you're going to hear from today represents a group of Denmark's leading innovators in the non-revenue water space. Current's job is to find those innovators, bring them in front of our audience, independently assess the work that they're doing, and help recommend them to bring them to ground. And so that's really the driving impetus behind this event and so many of the others that we do for our community. So with that, I'm really excited to turn it over to our partner today to introduce this topic. Michael Peterson, Senior Technical Advisor, again, from the Consul General of Denmark in Silicon Valley. Michael?
Thank you so much. My name is Michael Peterson, and I have a long experience as an operator and a head of operations in the Danish water sector. And, excuse me. Since September, I've been working out of the Danish at the Danish Water Technology Alliance out of the Danish consulate in Silicon Valley in California. The Water Technology Alliance are here to share knowledge from Denmark and across the pond. And we, among other things, doing this through partnerships with associations like Current. We are sponsoring this event series to create focus on a few of the topics and solutions that really have moved the Danish water sector. And I hope the input today can inspire and give some knowledge, and even open up for future collaboration. And if any of you are interested in talking more about non-revenue water optimization, digital transformation, asset management, and so on, or just would be interested in a walk and talk at your treatment facility, pump station, distribution systems, we're actually here to take this walk with you, and we would love to do it. And of course, we are fully vaccinated and social distance and things like that, of course. So please feel free and reach out. We're here. Thank you.
Thanks so much, Michael. Now we're going to turn it over to a dear friend of Current and one of our founding board members, Andy Richardson, the chairman of Greeley and Hansen.
Thank you so much, Lena. Thank you for the opportunity to share on this extremely important topic. You know, when I came in to this industry probably 4 decades ago, it was all about quality, and it's clearly now all about quantity. So the U.S. problem that we're trying to solve is reducing non-revenue water. So what is non-revenue water? Well, it's the percentage that reflects the difference between the amount of water supplied through the distribution system and billed to the customers. This percentage includes real and or physical losses like water leakage, apparent losses like illegal connections, water and meter inaccuracies. Maybe another way to think about it, those that had the pleasure of going to business school understood all about widgets. And you were taught that if you're going to make a widget, you want to make sure that you sell it for more than it costs to manufacture it. So if you sell a widget cost $1, you sell it for $1.01, everybody's happy. You sell it for 99 cents, not so happy. Maybe another way to think about it, we've all seen the ubiquitous McDonald's sign that say hamburgers over X billion sold. They don't say hamburgers over X billion made, because McDonald's, like water utilities, should be looking for the return on their investment. And utilities, it's really the return for the capture, treatment, and distribution of water. So if you look at this from an international perspective, the International Energy Agency said that about 34% of all water around the world becomes non-revenue water. And the problem clearly varies from location to location. In the United States, it's estimated between 10 to 30%, and in some places as high as 50%. Additionally, AWWA recently had recommended setting actual specific targets, like less than 10%, because they understood that each system is unique, and it's the understanding of those systems that makes the difference. And so rather than having a one-size-fits-all approach, in 2015, the AWWA Water Loss Committee approved a messaging to the water community and suggested that we should think in terms of 3 V's: volume of actual losses, volume, or actually the value of the apparent losses, and lastly, validity, accuracy of the data. So if you take a step back and think about this problem, it really kind of has 3 legs. The first is reducing apparent losses, which is accurate meter reading. The second is securing assets, which is pressure management and distribution management. And the third is reducing actual losses like leak detection. So let's look at the first. Reducing apparent losses deals with accurate meters. The water meter and advanced meter infrastructure, AMI technology, are constantly developing. It's fantastic what's been happening over the last several years. Optimizing accuracy, communication, battery life, data security, and handling are some of the themes often discussed. Today, water meters can not only actually count the water used, but can also do acoustic noise logging. This new feature, the noise inside the media, are monitoring to pinpoint leaks at both the consumer, but also in the distribution networks, creates a new, exciting diagnostic tool in water distribution systems called acoustic leak detection, or ALD. And we're going to hear more about that in a minute. The second issue, securing assets, deals with the management of the distribution system. Think about it. Stressing the distribution system with multiple changes in pressure over time actually eats up assets and cuts down on the useful life of the pipes and different materials. So the idea is controlling water pressure and managing it not only saves assets, it clearly reduces energy expense, but also improves customer satisfaction. The most advanced demand-driven distribution systems have a very impressive record of improvement of not only reducing where leaks are, but energy savings, water quality, operation, as I said, also customer service. The third issue is reducing actual leaks, and that deals with distribution system leak detection. Bursts and leaks will always be a challenge and something that water utilities need to be prepared for at any time. Having reliable and high quality valves that make it possible to effectively shut down the system and isolate those locations that need to be repaired are critical. Components in the distribution system network are so critical for acoustic leak detection, they're actually a bridge to the pipes underground. So valves, fire hydrants, distribution network joints to be used for acoustic leak detection, shutting off supply during repairs or breaks, and flushing is extremely important. And the most important aspect of this is having quality components that you can rely upon, that are resilient, and you know that will be reliable when the time comes. So quality definitely matters. So proactive leak detection really isn't for everyone, and you need a strategy. You need to find someone that has the skills, the experience, and the right tools and drive. And the need is for training, sharing experiences, techniques are important for leak detection so that your crew is efficient and doesn't end up with dry holes. In Denmark, there's one company that specializes in training, not only for leak detection throughout Denmark, but also throughout the world. And they're here today to share with us some of their experiences. So the question you may be asking, why should we be considered Danish technology? Well, here in the United States, we realized in 2001 that we were at the dawn of the replacement era. However, in Denmark, they've been working with old systems for decades. They have learned so much. So consequently, they have a proven track record of not only lowering the non-revenue water, but also having technologies brought forward that can help everybody around the world. So due to government regulations, targets, and penalties, water utilities have a long tradition for benchmarking and optimizing. In addition, the fact that all the drinking water in Denmark is based entirely upon groundwater, and that there is no disinfection allowed in the treatment or distribution system, the Danish utilities have been working very intensely to keep the distribution system network tight and to minimize leaks, definitely demonstrating their understanding of the value of water. Operating and maintaining old infrastructure and keeping it tight calls for innovation, and the Danes have clearly innovated. And that's what the Danish utilities have been doing together with their vendors. And we're fortunate today to be able to hear from some of them. And today, some of the world's largest manufacturers of pumps, valves, water meters originated from Denmark. So we are so fortunate today to have 4 front runners from the Danish water sector who will explain various solutions and share their experience, share their expertise and tools to optimize water distribution and reduce energy and non-revenue water to meet the demands that all of us here are looking for in the United States to be a utility of the future. Now, on a side note, I would be remiss if I wouldn't say that the other reason we should listen to the Danes is because they brought us Disney World. Yes, a Chicagoan by the name of Walt visited the Tivoli Gardens, spelled backwards, I love it, and got the inspiration for his theme parks. So just imagine the success and, more importantly, the fun we could have embracing Danish technologies to reduce non-revenue water, manage energy. And this is something, now wait for it, we're not Mickey Mousing around here. This is really serious stuff. Back to Elena.
Thank you so much, Andy, for that entertaining and thoroughly comprehensive overview of this critical issue. So important to highlight that. And now we're going to hear from our innovators. So I'm going to turn it right over to Robert to kick us off. And just a reminder to our audience today, please do submit your questions in the Q&A tab. I'll be monitoring them and weaving them in throughout the presentation. So take it away, Robert.
Thank you so much, Elena, and thank you for your introduction and also for yours, Andy. And I hope I don't Mickey Mouse around here and trying to just keep this whole thing going here. No, I think what you did with your introduction, both of you, was really, really great. And I'm also then pleased to kick into my discussion here. And my name is Rob Montenegro. I'm responsible for our municipal business here in the United States. And I work with Grundfos, who is one of the largest pump manufacturers in the world. And our purpose is that we pioneer solutions to the world's water and climate challenges and improve the quality of life for people. And that's a perfect tie-in, interestingly enough, to the non-revenue water discussion. And it it points to not only the importance of water as an asset, but also the energy associated with water. And we'll go into some of these discussions as we go forward. Next slide, please. If we think about municipal water and wastewater needs, energy is such an important part of the pumping and treating of water and wastewater. I've got some facts and figures here about the enormity of the energy needs for water and wastewater treating and pumping. 10% of a local government's operating budget, 3 to 4% perhaps of the total energy uses in the United States is related to water and wastewater pumping and treatment. And if we think about then the wasted water or the non-revenue water that's impacted, think about how much energy is used to treat that wasted water and move it around only to be wasted later on. So I think it's important that we look at this, and the participants will have an opportunity to get these slides so you can look at some of the specific details. Next slide, please. So if we think about a water boosting system, for those of us that rely on municipal water systems, the demand varies wildly throughout the day. Middle of the night, the demands are quite low, and then in the morning, showers and cooking and cleaning. In the evening, showers, cooking, cleaning, what have you. So there's a very, very wide range of needs of water and also of pressure for water. So it's important that water boosting systems have the ability to adapt to these wildly varying pressure systems. Next slide, please. And depending on the location of where you are, each municipality, certainly state by state or region by region, the requirements for boosting systems varies dramatically. Many of these water boosting systems are old. They have very, very large pumps that run at constant speed generally, and they run 24/7 to make sure that the person at the far end of the line has pressure whenever they turn on their tap. These are inherently inefficient systems. And because of the fact that they're pumping so hard, and because of the fact that there are varying demands depending on the time of day, this also has dramatic impacts on the piping systems. So there are pipe bursts often associated with these sorts of systems. And again, just the footprint alone from some of these examples that you can see is rather dramatic. So next slide, please. Again, there's facts and figures here. I'm not going to go through all these things, but this is a water supply audit from the city of Fresno, California. California is required by law to submit these water supply audits so that we can keep track of what's being used, what's being generated, and what's being lost. And you can see that in Fresno, roughly 50 million gallons a year are used, and 10% of that is lost to non-revenue water. It's a huge percentage. Also, by the way, they're importing 6 billion gallons of water a year. So they're importing 6 and losing 5. There's something wrong with that math, and it doesn't seem to make sense. So we've come and developed some solutions to help deal with these. Next slide, please. Yeah, so the way that we've done this is with our DDD system, demand-driven distribution. By coming together with a system that will allow the boosting systems to operate on demand rather than 24/7, we know that we can save an awful lot of energy. We know that we can save on those pipe bursts, and we know that we can provide water and not have the non-revenue water. Next slide, please. And the way that the system works, it's rather simple and rather basic. We have a boosting system, which is shown on the left. And then we install pressure monitors at various critical points, CPs, critical points around the system. And those sensors will then feed information back to the boosting system, telling it how and when to run, at what volume it needs, and what pressure it needs to meet the demands throughout the system. Next slide, please. At a very high level, the top chart shows what the pressure variations are at different points without the Grundfos demand-driven distribution, and you can see that there are massive spikes, both very high pressure and very low pressure, depending on the time of day, the demand on the system, the amount of volume needed, pressure in the system, et cetera, et cetera. And then after we install our demand-driven distribution system, We allow the system to operate for a period of time, a run-in period, where the system will learn what the maximum or what the ideal optimal pressure is that's needed in the system. And then when the operations team allows that system to run most appropriately, you can see that we level out the pressure in the system, and you can also see that it's at a dramatically lower pressure than systems that are not using this advanced technology. And then the pumps are able to run with the number of pumps needed, at the speed needed, with the flow and pressure needed to deliver the right amount of water and pressure at each of the different critical points, including at the end of the line, which is normally one of those critical points. So when you turn on the tap at night, middle of the night, then water comes out the other end. And one of the real critical points about this when we talk about non-revenue water is that when you have these pressure spikes and flow spikes through the pipelines, this is where you see the most common occurrences of pipe breakages, leakages, and so on. And by leveling out that pressure, you dramatically reduce the amount of pressure spikes and then therefore damages to piping systems. Next slide, please. So what are some of the results that we achieved by utilizing this demand-driven distribution system? 25% leakage savings, 25 to 40% energy savings, and 35% reduction in pipe burst occasions. So these are really, really dramatic benefits and savings that you can get from utilizing this demand-driven distribution. And again, when we tie this back into a non-revenue water position, think about a 25% savings in leakage. We're talking about real results. And I think that is my last slide. Are there questions from the studio audience?
There are. Thank you so much for that great presentation, Rob. I mean, I think you've really tied together so many of the goals that cities have around their water distribution systems and the connection that they also make to things like energy reduction, meeting our climate goals. I mean, this is really critical to figure out how to do this demand-driven distribution and help achieve these incredible impacts. I think one of the questions is there a scale of deployment? When we think about utilities, there are many different sizes and kinds of operations. Is there a particular scale of deployment that is, especially cost effective if you're considering the transition to this sort of D3 system, or is anyone able to sort of get in and try this out?
That's a fantastic question, and the simple answer is almost every single boosting system on the planet can benefit from a system like this. And we can design the system most appropriately with the right amount of pumps and the right sizes and shapes and flows and pressures required to meet these needs. So the simple answer is contact us, contact a local partner that we have in the neighborhood, and then we can get you turned on with the right solution specifically designed for that application.
And if you were advising people that were interested in, deploying this, what are some of the most important kind of preconditions or steps that they should take to be, able to roll this out more seamlessly? Are there things they should be thinking about ahead of time?
So this is another great question. So the simple answers are, again, what are the current challenges that those water systems have? Are there fluctuations in flow, fluctuations in pressure? Are they getting calls from the lady at the end of the line saying, I don't have pressure again, help me? Am I going through pipe breakages, leakages? Am I recognizing the non-revenue water challenges that I'm having? Those are prime opportunities. Also for those municipalities that are interested in exactly what you said, Elena, the combination or the nexus of water and energy. Yeah. How can I save energy? How do I save water? What's going to be the right thing for the environment? Then we have some tremendous solutions that we can offer.
So having great data and being able to listen to the customers on the front end, those are kind of important fact-finding.
100%, because this is not a one-size-fits-all solution. These are detailed, specific solutions for each one of the applications.
Great. One more audience question. So do you have any indication that these kinds of systems can have impact on the pipes themselves, like less stress on the pipes, longer lasting pipes, anything about the kind of longevity of the critical infrastructure that you'd see as an impact?
Yeah, fantastic question. And again, the better job that the systems can do to keep the pressure level rather than wildly fluctuating will have a dramatic impact on the life of the pumps, because you won't be putting that station or that piping system through the change in pressure, which has, you're introducing air and other air turbulence, other factors that will impact that piping scheme, and that will reduce the life.
Great.
So constant pressure is better.
Great. Thanks for that. I think we're going to go to our next presenter. We're going to hear from Kent Culbertson next. If we could tee up that slide. Great. Kent, take it away, and then we will, I just want to encourage the great questions from the audience. Keep them coming.
Can you hear me?
Perfectly.
Okay, great. I'm with American AVK Company. We've been in the US since 1985. AVK is an international company. We pride ourselves on providing solutions, not just products, and we're definitely not Mickey Mousing around. So next slide. This is an example of non-revenue water loss taken this winter from the AVK Distribution Center in Omaha, Nebraska. Next slide. We work with the WTA to provide free training to any utilities that are interested, and that's in various forms, including webinars. We have a very extensive online certified training program, and we also offer a AVK certified program at the factory, and it includes factory tours. Next. AVK products are designed for a minimum useful life of 50 years, and that provides the utilities with maximum return on investment. Next slide. So a lot of times we've heard the old adage that you have price, quality, and service. You have to pick two. With AVK, that's no longer a factor. Next slide. Every dollar you spend on AVK is maximum return on investment. Next slide. So one area that we excel in is areas where HDPE pipe is involved. And we have a fusible valve that fuses direct to the pipe. So river crossings, road bores, things like that, where you have pressure from water as the flooding occurs or temperature shifts, things of that nature. This prevents any damage at the joint. It's a joint-free system, and the valve on each side of the river or whatnot would not break. Next slide.
Oh, can you just pause 1 second? HDPE pipe, could you just define that for people who might be newer to this conversation?
High density polyethylene, where you either electrofusion or butt fuse weld the pipe, and this will allow you to fuse directly to that valve or actually our fire hydrant or flush hydrant. So it's a joint-free system. HDPE pipe initially had a little bit of an issue with expansion coefficient, and we've overcome that by making it not bolt to the valve.
Great, thanks so much.
So road borers under streets and highways are another example. If the valve's in the easement on the road right away, you know, you're talking about deflection, some other variables there, and the utility corridor can also be congested. And by fusing that valve directly to the pipe, you kind of eliminate many variables where you could have a failure point. Next slide. Another area we have developed is the AVK Hymax grip connection. And this is a self-restrained joint. You can connect ductile to HDPE, ductile to PVC, or even IPS to DIPS OD pipe on each side of the valve. And it's got a pretty good deflection capability built into it. Next slide. Another issue that we thrive in is bonnets on gate valves. And you might not think for non-revenue water loss this would be a factor, but I've actually been out on job sites and saw older valves where they actually have vice grips down in the vault holding the bonnet onto the valve. AVK Gummy is our own proprietary rubber company. And you can see here the bonnet gasket is retained in the body by not just the bolt, but also the way the valve is designed, and it prevents the gasket from extruding out and the valve therefore leaking undetected. Next slide. And along with that, we spend an extensive amount of time testing our bonnet bolts. So when you think about non-revenue water loss, one thing you might not think about is valve failure. But clearly we've tried to address this and prevent leakage at the bonnet. Next slide. We actually test every gate valve at 30 PSI, 250, and also 500 PSI at the factory. It has 100% traceability. And to pass the 500 PSI test, there can be no leakage through the valve shell or the sealed surface. Next. We actually do obstruction tests with 1/4-inch steel rods. Here at 1,000 foot-pounds of torque and 150 PSI of water pressure, it was leaking about a half a tablespoon every 2.5 minutes, which is 6 ounces per hour. Next. But at 1,176 foot-pounds of torque on the valve stem, the valve was actually drip tight. Next. What was more impressive was we were able to remove the 1/4-inch dowel rod, and with just 30 foot-pounds of torque on the valve, the wedge was drip tight also. So if you're trying to isolate a valve and you're trying to dewater a trench and you've got a lot of groundwater and different things involved, this prevents the valve from leaking and reduces water loss. Next. Corrosion is also a huge issue with appurtenances, especially with the increased use of PVC and HDPE pipe. The corrosion follows the path of least resistance. So cathodic protection is an increasing thing that's being used for fittings, and rather than thermite weld the anode lugs onto the valve or the fire hydrant, we actually have an anode lug, and you can hook 2 10-gauge wires directly to the valve. Next. We've actually worked with multiple companies to develop butterfly valves, including some AVK sister companies overseas. And butterfly valves are often used because they're cheaper than a gate valve, but one of the variables is they traditionally have often leaked. And we've developed the AVK Series 816, which is a butterfly valve that will not leak. It also can allow HDPE pipe to be inserted into the butterfly valve without beveling the pipe. Next. We spend an enormous amount of time on corrosion, and we try to prevent corrosion and deterioration of the valve bodies. And that includes what we call a holiday-free coating as an option on the interior of the valve. And if you have any questions about that, get a hold of us later and we can talk about it more. Next. We actually offer a polyurethane exterior coating. It can be up to 120 mils thick. It's sprayed over the outside of the valve over the epoxy. And basically, if you think about like rhino lining on a pickup bed or whatnot, instead of wrapping the valve, if you've got a ductile iron main, wrapping it with poly, you can actually just have them shipped from the factory with PUR. Next. Here's an example of a good application for the PUR coating. This was in Florida, and these are older valves that are being pulled out. The sea spray has deteriorated the valves after a few years, and with the polyurethane coating, you don't have to worry about that. Next. We're also very focused on fire hydrant coatings, and you wouldn't think about that as far as non-revenue water loss, but also one thing you need to be aware of, as the hydrant rusts and whatnot, if it's in a highly corrosive environment, you can have leaks due to bolts and whatnot. Here's an example of a hydrant on the right that's an AVK that was put in as a test, and after a year, there's negligible corrosion. Next slide. One thing that most utilities are very familiar with is the fire hydrant main valve leaking. AVK Gummy, again, has an incredible main valve for the AVK fire hydrant, and it's so good that we have a 25-year warranty on that. Next. Probably fire hydrants in the movies, when they're hit by a car, they spray. With a dry barrel hydrant, that really doesn't occur, but with a wet barrel hydrant, they can actually leak up to 8,000 gallons a minute if they're hit by a car. And so it takes an average utility about 40 minutes to mobilize, get their crew on site to shut the hydrant down and repair it. And if you think about 8,000 gallon a minute, that could be about 320,000 gallon of unmetered water lost. Next. So AVK developed what's called the FlowGuard 2 hydrant check. And this basically prevents the hydrant from leaking if it's a wet barrel, and if it's in a warmer climate, it's hit by a car. The great thing about this is it will fit any manufacturer's wet barrel hydrant. Next. When the hydrant's closed, the ball will settle and seal in a reverse direction. It also prevents backflow or cross contaminations. Next. Another thing we'll assist with is working with some of the smaller utilities on flushing programs. Annual flushing, as we know, is very important, but unidirectional flushing can reduce non-revenue water loss by about 40% because a lot of utilities actually don't meter their water when flushing. Next. Conventional flushing of fire hydrants basically involves no plan. The utilities often will just get out there and just randomly flush hydrants as they get the opportunity. Next slide. So we encourage unidirectional flushing. And again, if you do that and you have a plan, you can actually reduce water loss by about 40%. Next. So another thing we've tried to do, as some people were mentioning earlier, due to COVID, we've all had to rethink the way we do business. So we came up with an app called AVK Field Assist. Next slide. Basically, if you think about FaceTime, AVK Field Assist is very similar. It allows you to share your screen while the operator for the utility is on site. Next slide. Basically, they just download an app called Vuforia Chalk. Next slide. They'll then receive a code from an AVK engineer. Next slide. And what this does is it actually allows us to use virtual reality, and you can share your screen, or your operator can, on site. And then we can actually, our engineers will mark on their screen and show them what areas they need to work on. And the goal here, next slide, is just basically to address leaks quickly. So historically, the way this would work is we would have to mobilize somebody, sometimes drive or fly to a job site to try to help fix a check valve or a fire hydrant or a leaking gate valve. We can actually do it online now with this app. Next slide. So again, to wrap this up, basically non-revenue water loss is something that we're focused on. We realize valve and hydrants are things that you may not think about very often, but we encourage you to go to our website. We have a lot of resources there. And again, the free training, we have over 50 courses available at no charge. Next slide. If you have any questions, here's my contact information. And with that, I'll turn it back over to you guys.
Thanks, Kent. Just a couple questions if you can answer maybe succinctly, because I want to make sure we keep us moving here. There were questions about how different soil conditions and regional weather and chlorine treatment, what kinds of impacts those have on valves. And I guess I would say the broader question, you mentioned the Florida installation you're doing. What are some of the regional conditions and variances that people would want to have in mind as they're thinking about making this switch?
I actually was in on a podcast yesterday with Michael Rosenberg-Peterson, and we were talking about that a little bit. The interesting thing about the United States, or North America in general, is it's such a large geographic region, and you have areas that just vary wildly from one market to another. Soil conditions, the way they treat the water, all sorts of different variables. So I'm not going to be vague here, but I just want to say, if you have a situation where you have highly corrosive water and it's impacting your valves, your fire hydrants, get a hold of us, and we almost always have a solution to the problem.
Great. And then you mentioned this 50-year lifespan for the products. Do you have a sense of like how long the average municipality keeps valves in place before replacing them, or sort of, I know there's a lot of deferred legacy maintenance that needs to happen and replacement. Do you have a sense for that?
I think it varies. Fire hydrants, of course, you see a lot of those that may be up to 100 years old. And I think it depends on the utility's budget. It also depends. Now we're seeing utilities have valve exercising programs that, is preventative maintenance. So I think it depends on if the utility does reactive or preventative maintenance. And I would encourage them to get a hold of the manufacturer and try to come up with best practices. Again, it's a huge topic, so it varies from utility to utility as far as how many years they get out of that valve.
Great. All right, well, thanks so much, Kent. And if you have questions, his contact information is there. Karen, you are up.
Thank you. Are you ready to raise the bar on your smart water meter? It's noted that over 30% of non-revenue water comes from leaks on service connections. So finding these leaks can be challenging on so many levels. Time and resources are constraints, but it can also be difficult knowing where to begin and having a systematic approach on how to address these leaks. It's pain points like these that Kamstrup developed the Flow IQ 2200. It's the only ultrasonic smart water meter on the market today with integrated acoustic leak detection. So how does the meter work? The meter uses its ultrasonic sensors to monitor acoustic noise within the pipe 24/7, 365 days a year, and records the lowest daily value. The noise values are collected and the data is analyzed in Kamstrup's leak detector software. When the noise level trends are seen moving upwards, this could indicate a potential leak or burst. If identical patterns are seen on meters nearby, this also increases the confidence level that something in the area could be a leak. So what are some of the advantages of having acoustic leak detection integrated into a water meter? Well, one, you have good coverage across your entire water distribution system. So basically every water meter is doubling as an acoustic sensor. And secondly, there's no additional infrastructure, hardware, equipment, or cables to install or maintain. The data is automatically gathered within an AMI reading system, or if you're using a drive-by system, the data is collected automatically when you do your monthly reading and billing. And thirdly, it's monitoring for the life of the meter. So that's 24/7, 365 days a year for 20 years. And a lot can change over that time frame. So unlike these lift and shift loggers that are moved from one area to another, it mitigates that risk of not catching a leak after the loggers are moved elsewhere. And then lastly, being able to prioritize your resources. So having the insight into where to start looking, you save time and you can focus those leak detection efforts where it's going to make the most impact. Next slide, please. So I just wanted to share a couple examples of two utilities who have used this ALD technology to find leaks within their water system. The first one is Crystal Clear Special Utility District. They're located just between San Antonio and Austin, Texas, and they started this program mid last year. So this utility started decades ago. It was a bunch of farmers and ranchers that had to get water to their cattle. And today they have over 6,000 service connections. They supply over 1.8 million gallons per day. And they have very rocky terrain. So typically the leaks don't surface until they become a bigger problem, leaks or bursts. But 2 months into the project, they noticed this leak right here. And as you can see in the graph, the noise level gradually rose and the meter on the blue line had a leak about a foot from the meter box. And this was a pretty significant leak. It was leaking at over 1,000 gallons per day. And you can see there were a couple meters nearby that also picked up the same noise trend. So this is how they can correlate that there is something that all these meters are hearing in the area. And just the way this meter was piped, they said that it helped them find a leak that they would have not known to look for. Next slide. Second example here is Ephrata Joint Area Authority. They're just an hour west of Philadelphia. And again, they started this project with us last year, and they noticed a huge spike in the noise level on this particular meter. And they went out with their ground correlators and they were able to pinpoint where the leak was. And it was on a 12-inch main. It was leaking from a stainless steel clamp about 55 feet from where the copper service line was. So again, this is an example of a leak that they wouldn't have found until the situation got much worse. Next slide. That's all I have for today. So there's my contact information if you have any questions.
Okay, that's great, Karen, because there's a lot of questions. So I'm going to go ahead and jump in here. Just from a technical perspective, an audience member's curious how you differentiate leaks from just normal usage with this acoustic approach.
That's great. So the meter actually takes 26 short measurements a day, and we do that to filter out background noise. And also if there's flow in the meter, so if someone's using water in the household, it postpones that measurement. But however, if there's a constant leak on the customer side, we also display a leak flag in the software so they can tell, well, this noise may be attributed to a customer side leak. Great.
And how far out in the distribution system are you able to detect leaks? Is there a, threshold there?
That's a great question that we always get asked all the time. So there's no set distance, and it all depends because it depends on how noisy the leak is. So if there's noise in the pipe, then it's going to pick it up. However, there's no noise in the pipe, then it's not going to pick it up. And that's like this, leak detection world, it just follows those same rules. But we have had cases where it was picking up, up to 500 feet. Now that's like an extreme example.
Mm-hmm.
And then we've had leaks that were within 6 feet away and it couldn't pick it up. And we had various, differences in, pipe material, metal versus plastic, and so forth.
Yeah, a lot of variation there.
Yeah.
And then how about, just thinking about all of the infrastructure and construction projects that are likely to be happening in water systems, how do you filter out or deal with like the massive ambient noise from those sorts of, interventions in the ground?
Right. So, typically if the noise level reaches a certain threshold, we advise, you might want to keep an eye on this one, go out and look. And then once you get your leak detection crews out there, you'll be using either correlators or ground mics. And so then you can figure out, is this noise really being generated from the service side, or is it a customer side? But on the meter itself, you can see if there's flow going through the meter at the moment. So if you listen in with like a listening stick, you can see if there's noise when there's no flow.
Great. And then last question, are these meters something that consumers and water users can install themselves, or is this only system level? Like if you're curious about your own usage.
This is only going to be system level. So basically your utility would install this meter.
Great. Well, this is a fascinating area, and I know many cities are looking for more of this smart metering. So thanks so much for that presentation. And we're going to now
Thank you.
Wrap it up with our final innovator. We're going to hear from Jørgen. So Jørgen, over to you. Jørgen, you're muted. We can't hear you. Can you unmute?
Oh, thank you so much.
Perfect.
Thank you for the floor, so to speak. I'm going to talk about proactive leakage detection, and we will come across about some systems, but mainly about the way to do it. Please, next slide. Thank you. What you see here on the slides is our partly of our training facility, where we do the training of staffs from around the world here in Denmark. We also do training abroad, everywhere in the world. And I'll say that the general idea with the leakage detection, proactive leakage detection, is to have the master plan, so to speak, to find out what methods is the most comprehensible in each area. I'll come back to that later. Next slide, please. As I mentioned, the master plan, what to do, how to do, to maintenance the plan, there's a variation of systems which we heard about, just Kamstrup's noise logger inside the meter. That's a really good idea. And you can also place loggers outside in the system, and that could be a good idea depending on the material. We also use correlators and ground mics as stated. So where we start is to taking the master plan of what is the job, what is the situation, what is the goal? If we see here in Denmark, as it was in the opening speech, very, very fine, stipulated, 2.5 decades ago, 25 years ago, we had a consumption about 60 gallons a day a person. 25 years later, we have halved the consumption. This is not directly by leakage detection, but it's also by leakage detection. But in the same periods, the leakage percentages is going down from about 15-20% to below 7% losses. So when you think about the percentages in the plan, you have to think about what is the consumption to get the amount, the total amount of the leakage. It's really important in the master plan to calculate, to see where is the loss, where is the actual loss, and how big is it in terms of gallons. We do the training and the master planning from up north in Greenland, plus 120 Fahrenheit. We work in the desert, minus 50 Fahrenheit. So it's another thing. There's in the US, there's also a lot of different conditions. You need to be waterproof, and you need to be able to work in the heat and as well as in the cold to have. And that goes for the staff as well as for the equipment. The training is after the master plan, step number 2 in proactive leakage detection. And that's also a very important goal. The master plan is the foundation, and that's really, really important to start there, where to go after we have valves who shut down and meters and pumping systems and stuff like this. The actual leak out there, to find them, you also need to have a master plan. After developing the master plan, it's training to find out which kind of equipment system is comprehensible in the different areas. There's a lot of variations of systems, and you're very welcome to ask into the single one. I will not go into deep of the techniques with that. That will be in the next line. Next slide, please. Next slide, please. Thank you so much. I think I've spent my 5 minutes, so I say thank you very much for the floor. Thank you for listening. I hope you have some good questions. I'm ready here. Thank you.
This is terrific. So the first question, right behind you, you've got the Sustainable Development Goals up on the screen. That's a really nice feature there. So when you're talking to cities about the value of doing leak detection, what are some of the things that you highlight in addition to the cost savings? Because, with the Sustainable Development Goals up there, obviously achieving, climate resilience and many other things are sort of achieved by, making these investments. How do you talk about the value?
We start find out what is the situation. Are you purchasing water? It's one price. The resources, you cannot price the resources. If you don't have more water, you'll have to desalination or something else, very costful or extremely costful if you have to turn the way of the water. So we start to find out what is the impact of the leakage compared to both the finance, of course, and of the resources. And then we calculate back to see where are you? Do we have a loss on 5, 10, 15, 20% loss? Mm-hmm. And where is it possible to go? And then we will recommend to use other systems as well. We focus on the leakage. So it's very varied. Some places the last drop of water costs the same as 10,000 gallons of the first one. So it's the value both in resources and finances is very varied.
Right. Well, with that variation in mind, I'm sure there are lots of answers to this question, but are there some like high priority or quicker fixes that utilities and municipalities should be thinking about when they're looking to reduce non-revenue water? Are there often some like low-hanging fruit things they can do?
Yeah, there are some low-hanging fruits. With simple methods and simple training, You can go out and listen and find the leaks, pinpoint them with a correlator, and most places you'll be able to take the top of the leakage, and that is very quick. It's a quick fix. It's cheap, and it's compared to do other changes. It's often the quickest way to save water. And then, but the long-term plan is important to follow up.
Yep. And is this something that really any municipality can learn to do, like figure out how to do leak detection if they don't already have that in place?
Yeah, that's definitely yes. It's more about the mindset. If the leak noise detector is yellow, blue, or green, it doesn't really matter that much. It's the mindset of the guys, the girls, the guys who's working with it in the field. And this is, I would say, when we do the training, half of it is like mindset training, because it's the mindset to evaluate the information and to change the system, to use another system on another job. That's really important.
Right. It's really
the same instrument for everything. Then you will work many waste hours.
Yeah, yeah. So it's really a culture shift and a practices that support that. Yeah, great. And I think a final question: if you had to offer sort of one piece of advice to utilities that wanted to get started on this journey, what are some of the things they should do internally to prepare to get smarter about non-revenue water?
Well, the first thing, just take the decision. We want to reduce it, and then start up with you can start up more or less immediately.
Great. Great. Well, thank you to all of our Danish innovators today. This was a really terrific conversation about something that is certainly going to continue to be top of mind here in the US and around the world. I want to encourage everyone, of course, we'll be sharing the recording from today's presentation. It will include contact information for all of our fabulous presenters. So please follow up, find out more information, and then join us. Stay in touch with Current. We have many good events coming up virtually over the summer and into the fall. So please stay tuned for that. Follow us on social media. And then we've got 3 events kind of highlighted here. And just stay in touch with us. We are always excited to develop new partnerships. We started the year really building out this exciting Water Around the World series. I'm very excited to have our partnerships with our friends in Denmark. And if you'd be so kind as to fill out a really quick audience satisfaction poll, we are always excited for your feedback, especially as we sort of all start to spend more and more of our time out of the virtual world and out in the real world. If we don't get to go to Disney World, maybe we'll get to go to Denmark. That's what I'll leave you with today. I'm really excited about the opening that all of us are experiencing. So thank you all. Thanks for joining us. Thanks for spending some of your morning with us. And again, stay in touch.
Okay.
Take care, everyone.
Thank
Thanks
you.
so much.